A method is a little bit different. And you can see here, this class called CLCar, I've extended it a little bit. It has a property there in blue called int miles. Int miles is originally is set to 100 initially. So whenever I create an instance of CLCar, that instance starts out with 100 miles. Now it also has a method in red there called driveCar. And driveCar takes up an argument called int how far. It also has this word in there, self. You will include that in every method inside your class. So that allows you to access the properties of that class. That gives you access to those things. So including self right here allows you to do this, which updates this. So I'm saying self.int miles, however far you drive, gets added to the int miles, and then it reflects those numbers back to you. So let's take a look at this in our code window here. It's going to want me to properly indent things. There we go. And why are we using smart quotes here? Okay, there we go. All right, so there is, let's give this some space here so we can breathe a little bit. Okay, so up there on line 1, we have the class definition. Starts out with the word class, and then it has the name of the class, CLCar, and the colon. Everything under that is indented that's part of that class. So int miles is equal to 100. That's a property of CLCar. The driveCar method takes self and int how far as parameters. Okay? Self allows us to access the properties of that class. Int how far is a number that you have to give it to tell it how far that car is going to drive. So what it does is it takes int how far, adds it to int miles, which changes the property value, and then it reflects those things back. So when I drive this car, if I run this, you can see you drove 50 miles, mileage is now 150. But if I say my car 2 equals CLCar, I've created now a second instance of that car, which is totally separate from the first one. If I print my car 2 dot int miles and I print my car dot int miles, you can see that the miles value for each one of those cars is separate, because just because I drove one car doesn't mean I drove the other. So now I have two separate cars with two different mileages, but they both have the same ability. They both have the ability to drive, and they both have int miles. Now this is a very, very simple version of a class, but we're just getting our way into it here. Okay, so in the same way, if I wanted to extend that example to the turtle, let's go back to this, and I'm going to invoke Python here. Let's import the turtle. Oops. Import turtle, and now I'm going to say t1 equals turtle.turtle. Okay, so there is one. And let's make another turtle instance. T2 equals turtle. And a few of you in this class have discovered that you can do this by accident. Okay, so now you can see that I have two turtles going on here. Okay. So now I can use those turtles. Let's say if I wanted T2 to go to T1 dot position. So I can use the position of T1 to tell T2 to go to that spot. So I can use those turtles interactively because I know that T1 position returns a tuple that has an x and y coordinates, which is what goTo needs to function. But the positions of those turtles, let me just show you, are not the same. So I have T2 position, that's the position of T2, and I have T1 position, which is different. They have different properties. So each of these they're both based on the turtle class. They both have the same abilities. They can draw circles, they can do everything. One can do everything that the other can do. They have the same abilities. They have the same variables associated with them. An X position, a Y position, the direction they're facing. All of those things are variables that are contained inside each of those turtles that I can read and write to and change. But the variable values are different. The position of this one is different than the position of this one. So that is one of the values of using objects, because you can use that blueprint to create multiple instances of those objects.